So we are live. Hi everyone, welcome back to Geeks for Geeks practice. Today we'll be discussing the problem of the day for yesterday, and that is money distributions. Let me show you the problem. So this is the problem of the day that we'll be discussing today. So you can consider giving a +1 in the chat, and you can like the video if my voice is audible to all of you, so that we can begin immediately. Okay. I'll just wait for some time for others to join, and immediately after that we'll begin with the session. Okay. When will it start? Okay. Right. So I'll just be waiting for a couple of minutes for others to join, so that they do not miss the problem of the day. Problem statement for the problem of the day, and after that immediately we'll be discussing this problem. So this was a medium level problem, and apart from this, like, there were 65,000 65% is the accuracy rate, and there are 2000 submissions, 2000 plus submissions for this problem. I think that this has not been updated for a long time, and the problem offers you 4 points, right? So this is the problem of the day. How many of you were able to solve this problem? You can mention that in the comments, and if you were not able to solve this problem, then you can also mention that in the comments. Okay, so I'll be reading your comments quite fast. Okay, Vaibhav Negi is giving a +1. What about others? I'll just be looking into your comments. Okay. Right. Shall we start? Shall we start if everyone is ready? Shall we start if everyone is ready? Right. You can just comment down below if everyone is ready, then we should start. Okay. Right. Okay, let's start. Okay, thanks Sridharan. So the problem says that you have to find the minimum number of ways in which n coins can be distributed among k pupils such that each pupil is receiving at least one coin, and two distribution will be said to be different if at least one pupil got different number of coins, right? So if you take n is equal to 7, and for this the number of pupils are 3 for this case, then the output will be, for this case the output is going to be 15, right? So how do you get this? Let's just quickly see. So let me just paste these. So if you will look into this, so these are the types of distributions that you can have, right? You can first of all, you will be having 3 kits, right? So first of all, you can do 1 1 and 5, right? This is possible. Then you can do 1 5 and 1 5 and 1 as well. After that you can do 5 1 1 as well. And next up, what you can do is 1 2 4 1 2 4. After 1 2 4, then 2 1 4 is also possible. Then 1 4 2 is also possible, right? And then 2 comma 4 comma 1 is also possible. 4 comma 2 comma 1 is also possible, and 4 comma 1 comma 2 is also possible. After that 3 comma 1 comma 3 is possible. Then 1 comma 3 comma 3 is also one another combination that you can have. Then 3 comma 3 comma 1 is also a permutation which you can have. Then 2 comma 2 comma 3, and 2 comma 3 comma 2, and 3 comma 2 comma 2, right? So in this way you can have 15 permutations, right? Everyone agrees on this? Like, how do we get there? So we'll be discussing about like, how do you actually get there, right? Is everyone clear with the question? Is everyone clear with the question and the distributions? Like, this distribution is different from this distribution because you can see that this index and this index, like this child, this pupil and this pupil are getting it different, right? Getting different number of coins. This pupil and this pupil are also getting different number of coins, right? Everyone is clear with this? Everyone is clear with the sample test cases? Only then I can consider moving ahead, right? Everyone is clear with this? If everyone is clear with this, give a +1 in the chat quite quickly, and please like the video. Okay, if everyone is clear with the problem statement, please give a +1 in the chat and please like the video so that we can proceed further, right? Shall we proceed further with this question? And what you can do is, if you have solved this question, so you can suggest me like how should we doing it, how should we do it, right? Is the problem statement clear to everyone? If the problem statement is clear to everyone, then please consider giving a +1 in the chat quite quickly. Only then I'll be moving ahead. Okay, shall we move ahead with this problem? Right. I'm still waiting for your responses, because if you have understood the problem, only then we can move ahead. Otherwise, I'll still be waiting for your replies. Okay, if the problem is not clear, then I can clear it again for you. So whatever is the case, you can just quickly tell me. According to that, we'll be moving on. Okay. Okay, +1 clear. Okay, so everyone is clear with this, right? Let's look at the next test case that has been given. So if you have been given 5 and 5, and you have been given, if you have 5 children, if you have 5 money, the amount of money is 5 and k is equal to also 5, so you can distribute 1 coin each to every child, and in this way your 5 coin will get exhausted, right? And there is no other way, right? Since the answer can be wrong, that is why since the answer can be a bit too long, so that is why you'll be printing the answer modulo 10 to the power 9 plus 7. Now from the problem statement, it is very much clear to all of us that with the problem statement, you can see that this problem is of mathematics, or you can say combinatorics, right? Because you have to print the number of different distributions, right? You have to print the number of different distributions, right? This is what you have to do, right? Everyone will agree that you have to do this, right? So how do you do this, right? So if you will see, so one thing that you can observe is that of all pupils sum of all pupils means sum of the distributions that you have given to all the k pupils is nothing but n, and this is very much clear, right? This has been given in the problem statement, right? Now let's say that I give k1 amount to the first one, I give k2 amount to the second student, k3 amount to the third student, and in this way I give kk amount to the kth student, right? So all this will sum up to n, right? Everyone agrees on this? Everyone will agree on this part as well, right? Right, everyone will agree on this? Everyone agrees on this part? Like this can be the possible cases that I can distribute k1 number to the first, k2 to the second, k3 to the third, right? This can be the ways. Let's suppose I am distributing in this way for all the students, so that will sum up to n. So ultimately every time I am distributing, so my sum would be remaining the same, right? My sum every time would remain the same because it won't be changing. Yeah, right, perfect. So how do you do this, right? So also notice that each pupil should get at least one coin, right? At least one coin. This is something that you need to notice, that each pupil, every time you distribute it in any order, each pupil should be getting at least one coin in a particular distribution, right? Because it should not be zero, right? So so what will happen with this? What will happen with this? So if you will notice it in a much clear manner, so you will be getting a formula. Okay, you will be getting a formula, and what is that formula? Can someone quickly in the chat tell me? Can someone tell me like what will be the formula for this, such that you distribute every time and the students are getting at least one, right? Can someone quickly tell me in the chat, like what will be the formula looking like? what I can see a lot of people are watching, so you can consider giving a like to the video if you haven't already. So how should you distribute in such a way that each pupil every time you distribute it, each pupil should be getting at least one coin should be given to each pupil each time, right? So how should we distribute in such a way? Can someone in the chat quickly tell me? I just wanted to know this much part, right? Can someone in the chat tell me like how should we distribute it? Can someone in the chat tell me how can we do this? Like what can be the formula such that you distribute in such a way that each ki, let's say ki, so ki should be every time greater or equal to 1, right? It should be at least 1, right? This is the case. So how should you be distributing it? How should you be distributing it in such a manner such that in the end you get this, right? How should you be doing this? So I will tell you what you can do is you can simply observe that what you can observe that this is a combinatorics problem, right? So this will be the answer will be nothing but NCR into n minus 1 comma k minus 1, right? This will be your final answer. Why? Because what is happening every time is you have to distribute, you need to only consider this situation, and everything like permutations of all the combinations and all the possible combinations can be got through this formula. Only one thing that you needed to notice was each pupil should be getting at least one coin each time, right? So the formula for that will be directly this. Why? Because each time every pupil should get at least one, right? So this formula, this particular formula will take care of all the cases, right? Okay. Yeah, right, perfect. This what is the formula, right? This is nothing but n minus 1 c k minus 1. Okay, you can say k minus 1. Why? How does this work? So this works because this is the formula when you have to distribute each pupil. Only one thing that you needed to notice, that each pupil should get at least one, right? Each pupil, sorry, let me change the color of the pen. Okay, each pupil, uh yeah, each pupil should get at least one coin, right? So for that the formula is this, right? So someone is asking like how do you get such formula, right? So this is a pretty standard formula, like you can google it. Like you have to distribute n coins, you have to distribute n coins in such a way such that every pupil gets at least one coin, right? All the k pupils get at least one coins, right? So you have to distribute n coins in such a way that every pupil gets this, uh every pupil, that is all the k pupils, get at least one coin each time, right? And you have to print all the different combinations, permutations and combinations for that, right? So for that the formula is simply this: n minus 1 c k minus 1. That is, you will be taking the combination of n minus 1 ck minus 1, and you can directly, I hope that you know what is ncr and what is npr. I am assuming that you know about this, right? So since you can see that this will be what, just quickly tell me. This will be nothing but n minus 1 factorial into k minus 1 factorial and n minus k factorial, right? So you can see that there will be this numerator, then there will also be denominator, right? So since ultimately you have to print this value modulus mod, so that is why you will also be using the inverse modulo concept and the power function as well for doing this, for multiplying this function, for multiplying this, right? Because this is the standard formula for this, where let's suppose that you have n amount and you have to distribute it among k people such that each people should get at least one value, right? So that is why you use this formula, that is n minus 1 c k minus 1. This is a pretty standard concept. If you want, you can google it and read about it, because I think this was taught in some smaller class, like 10th or 12th. Okay, so let me just show you the code part for this problem. So what we'll be doing is, first of all, you will be writing your code here, right? What are the some of the edge cases that you need to notice? That if k is greater than n, right? If k is greater than n, what is k greater than n, right? So if k is greater than n, what is k? So let's suppose that k is greater than n. So if the number of pupils are greater than the number of money or the coins that I have, so in that case I will not be able to give at least one coin to each, right? I will not be able to give, not able to give at least one coin to each pupil, right? So that is why I will simply return 0 in this case, right? This is a particular edge case, very straightforward edge case that we needed to take care of. After this, what we'll be doing, right? After this, your formula will be this, right? That is, if at least, if you give at least 0, right? If at least 0 can be given, then in that case your formula will be n plus k minus 1 c k minus 1, right? And if you want to give at least 1, so in that case the formula will be n plus k minus 1 minus k comma ck minus 1, right? And if you will further optimize this, so the formula will be nothing but c n minus 1 ck minus 1, right? And once you have this, so you will put your n is equal to n minus 1, small r is equal to k minus 1, and after that for your r you can choose the minimum among r and n minus r. After that, simply you will be initializing your mod as 1e9 plus 7, and once you are done with that, you will initialize your answer as 1 because you want to find the combination for this, right? So what you will be doing is you will be first of all calculating the numerator. So for the numerator part, it will be very much easy because you will be directly multiplying your j value. J will be where j starts from n, so you will be directly multiplying your j value where j will be decrementing each time, that is n into n minus 1 and all these things. Basically your small n will be starting from capital N minus 1, right? So you'll be each time you'll be multiplying your numerator, and after that, once you are done with that, so what you will be doing is you will be since you have also to check the denominator part, right? So you could have directly calculated the denominator part as well, but since you want to take the modulo, so if you want to take the modulo with 10 to the power 9 plus 7, so for that we have to deal with it separately. So for doing such things, when you are dividing and you have to take the modulus, so in those cases what you do is you use the bin power or binary exponentiation, you can say. And what you do is you pass power with I plus 1 comma mod minus 2 comma modulo mod, right? So this is the bin power function that we usually use to do this. If I'll explain this, then this will take another video of half an hour, right? So what we do in this case is you check that you first of all you initialize your resultant answer as 1, and you check if your b is existing, that is the you can give power, that is if power is existing, then you will check if the power is not even. So in that case you will be directly if the power is odd, so in that case you will be multiplying it to the result, you will be multiplying a to the result, and after that you will be dividing it by 2. And what you will do is if the power is odd, so in that case you will be multiplying it by 2, right? So this is fast exponentiation in a bin power binary taking the inverse modulo, right? So that is why this will become very fast, right? So ultimately this can be done in this function can be this particular task can be calculated in order of n time, right? I can see a lot of people are watching, so you can just consider giving a +1 in the chat, and you can like the video if you haven't already, right? After that you will be returning your answer. So this will calculate my denominator part by taking the modulus as well, right? So this will help me to calculate n minus 1 c r minus 1 ultimately, and after that, once that is stored in my answer, so I'll simply return the answer. Now you will say that why am I multiplying this denominator part into my answer? So that is because I'm taking the inverse modulo for the denominator, because for the denominator, if there is denominator and I want to take modulus, so for that that is not possible directly, and we have to calculate the inverse modulo for that particular part, and after that we can directly multiply it, right? So I hope that this much part is clear. And is this code clear to everyone? If this code is clear to everyone, then please consider giving a +1 in the chat quickly, so that I know that everything is clear, like the code part, because there was nothing much in this question. Only you needed to know the formula, that is n minus 1 c k minus 1, and apart from this everything else was simple, right? Okay, everyone is clear with this part? Okay, so just to show you that my code is working, I'll just submit it right now. So you can see that I have just submitted my code. So let's see if it works or not. Okay, so you can see that it got accepted in 0 0.1 second, and this was the code part. And now let me tell you that the problem of the day for today is find the nth root of m, right? So you have been given a number m, and you have to find the nth root for that. So this is a popular problem. It has been asked in various companies like DirectEye and other big companies. So you can consider solving this problem for today, and we'll be discussing this problem tomorrow. Okay. Okay, so if you haven't liked the video, so you can please consider liking the video, right? And since not many people are having any doubt, so I'll just wait for 30 seconds more. If you haven't liked the video, you can like the video. If you have any doubt with this question, you can ask. If you have any other doubts, you can also ask that. Consider asking that as well. So let me show you the code part once again. You simply have to calculate n minus 1, c k minus 1, and for that what you basically do is you first of all multiply the numerator directly, and after that for the denominator, since you have to take the modulus 10 to the power 9, so for that you have to calculate the inverse modulo for the denominator, and you will be doing this using this function, and this function will help you to optimize your answer. Why? Because it will be calculating your power in log n time, right? So that is why ultimately in order of n time you will be able to do this, and the space complexity for this question will be order of 1, right? Everyone is clear with this? If everyone is clear with this, and please consider giving a +1 in the chat, and please like the video if you haven't already. Okay, so you can consider subscribing the channel, because on this channel we bring regularly the unboxing interview series, and